Well, hey there everyone. My name is John Grimsmo and this is another Knife Making Tuesday. I got a really cool one to show you this week, one we just finished yesterday, and it needs one final little finishing touch, a custom engraving to match the guy's last name. So first let's show you this beautiful, beautiful Norseman here. So this is our Grimsmo Knives Norseman. It has thunderstorm Kevlar inlays, which is Kevlar, which has been woven with, believe it's copper or brass wire. I'm not really sure. Really awesome. Stonewashed titanium handles, anodized nice dark bronze, brushed edges, blue spacers and thumb stud, and Damascene steel blade. Now Eric has absolutely figured out how to etch Damascene steel. We were using sulfuric acid for a long time and just weren't getting the etch that we wanted, and then after talking with the guys from Damascene steel, from the company, we switched over to muriatic acid, and yeah, that's nice, huh? Just absolutely gorgeous. Nice dark edge. Anyway, so that turned out awesome. So as for the finishing touch, the guy's last name is King, so he wanted to put a crown somewhere on the knife. Now with an inlay design, there's not a lot of places to engrave something. Like, you could go in there, but it's really small. Usually I'll put an engraving right here, but that's where the inlay is. You could put a little one on the lock bar or up here maybe, but I was thinking, what if we put a little crown right at the top of the clip right there to accentuate the little Viking head, which always looks really nice sticking out of the pocket, but a little crown sticking out the corner of the pocket I think would be pretty choice. So in this video we're going to go over how I take an image and turn it into a vector file, and then to a DXF file, and then to a SolidWorks file, and then manage it in SolidWorks, and then using HSMWorks we're going to make the code to engrave this wicked awesome crown, and then we're going to move over out to the garage to the Tormac and engrave this crown. So here we go. So as I said, the customer's last name is King, and he sent me this image and he said that crown is pretty cool, that's kind of what I would like on my knife. So I have to take this image, which looks like a photograph of an image, like a graphic or a sticker or something. So it's kind of grainy, kind of not crisp or anything like that, and there's no definition. So one thing I can do is I can import this into SolidWorks and I can draw lines across all the corners and just sort of redraw it, which for a sort of simple image like this is probably the way to go. And I guess that's how I ended up doing it anyway. So I've got a program called Vector Magic, where I cut out the crown from the image in an image editing program, and then I go into Vector Magic and I click fully automatic, and it crunches and crunches. So here is the Vector Magic file. You can see here's the before and here's the after. It blends all of the features into very simple lines and simple colors instead of all these fades and stuff. So that works pretty cool. And then more importantly, it finds all the paths, all the edges. It just knows where they are, which is great for CNC. So then you can go next, and then you can export as a DXF file, which SolidWorks can read. Go into SolidWorks. I'm going to open up a new file, and then insert DXF. Well, first you have to pick the top plane. There it is. Now there's a trick here that I recently found out. It was driving me nuts before. Sometimes I would just hit finish, but that doesn't always work. Since I chose 3 colors in Vector Magic, white, black, and whatever that color is, it imports as 3 different layers, and you don't want that. So I'm just going to import one set of lines. And then you can also, on the next screen, merge points closer than, I'm going to say 5/1000ths of an inch, and that seemed to work good. Otherwise you get little gaps between the lines, which doesn't extrude properly. So I'll finish that, and there's our file. Now, this file is 11 inches long, which is way too big to do anything with. And you can see there's all these tiny little lines connecting everything. So it's a lot of line data, a lot of information to crunch. What I'm going to do is I'm going to delete the outside line, because we don't need the outside, we just want the inside, and I'm even going to delete these extra little lines. So there is the rest of our crown, and I realized we don't actually need these swoopy bits inside because they look kind of funny just by themselves right now. Alright, so here's the original crown file, and you can see the size that I'm going for now. I think it's 5% of the whole size, or something like that. Here's my original file. And then I went through and I just drew new lines. I took the line tool and I went line, line, and then I took the spline tool and I just matched the contour kind of like this. Because this gives me very simple lines. You know, it's one line. It's not all these little tiny lines. So it gives a much cleaner engraving, a cleaner image to work with, and you still have the reference of doing it before. Like I said in the beginning, one thing you can do is just say you want to import the image itself and then trace over it, which is basically what I just did. A sketch first, the top plane, sketch, and then you can go tools, sketch picture. Let's pick his vectorized one. You can see how enormous it is, but since it's just a picture we can crop it down, no problem. So there's our picture, and then we can draw our lines across it like that. So those are all my lines, and then here's my spline tool. And hit the transparency so we can actually see our lines. And then the spline tool, and then I can just kind of match this contour like that. Not the cleanest, but I'm just doing this real quick here. So anyway, that's basically how I did that. Or that's how you can do that. So then I selected it and I extruded it just to help me with the CAD a little bit. Okay. Close that. So here is one of my main files. This is where I do all my handle work and all my clips and all my thumb studs and all my spacers and all kinds of stuff. It's probably bigger than it needs to be because it tends to be a lot for the SolidWorks to handle, but that's okay. As you can see here, I've got my honeycomb files for the lefty and righty. I got some engravings. I got all kinds of stuff. It's really complicated. Okay, so we're doing the crown. I've imported it right here. I've sized it properly. I'm going to select the crown, the clip, and the handle, and right click and then go isolate. And now I have just the handle. And what's really important is that SolidWorks is only viewing these things, it's only crunching these things, so it's much faster and snappier. So that's good. So here's the crown we're going to do. You can see I just laid it right on top of the clip. I'm going to engrave it at this funky angle because I think it'll look cool that way. Now we're going to bust into HSMWorks, which thankfully is integrated into SolidWorks. It's right here. Just click at the top here at the feature tree. This last little tool is the CAM Manager for HSMWorks. This is where I have all my codes that I've used to do my handles. So I moved it because I don't actually engrave the clip in this position while it's attached to a handle. I have to exit isolate, see the whole thing. This is my clip fixture where I screw down all my clips, and this is where I will be engraving the clip. To do an HSMWorks file like toolpath, first thing you need is, I like to use a coordinate system. So right here is my x0, y0, z0. This little dot on the surface of my fixture. Okay, and then there's actually a coordinate system. Let's see, how can I figure this out? Yeah, a coordinate system right there. So I put a little dot or a circle or something at the exact spot that I want. Usually, this clip's kind of weird. Usually there's a precision hole here that I can use my digital probe to like probe that center and make sure that my machine knows exactly where that hole is. This clip fixture is weird, so don't think too much about that. But anyway, so I put a little dot. If I hide this, you can see there's my dot. And then I go Insert, Reference Geometry, Coordinate System. Okay, and then I click on that point, which is already clicked on. And then you need an X, Y, and Z reference. So X is perfectly left to right, so I'll click on that edge. Y is perfectly in and out, so I click on that edge. And Z is up and down, so if I want I can click on this edge. Okay, now these are wrong because Z is pointing down, which is wrong, so I'm going to flip that around. Okay, X plus does not go to the left, it goes to the right, so I'm going to flip X, and then now it's perfect. Z goes up, X plus goes right, and Y plus goes forward. So there's my coordinate system. And that's it took me a while to figure out how to do a coordinate system so that HSMWorks can get a perfect reference location. Okay, now that I have a coordinate system, you start a new job. So you basically right click anywhere, you go new job, and I'm going to cheat and use my existing job. The model, when you open up a new job, it's going to default select everything in your drawing, and for me that's a ton of stuff. But all I want from my model is this clip right here. So I'd click on that clip. For stock, I want automatic because it'll look at this clip and it'll make like a square around it. No additional stock. And then work coordinate system. You can do it a couple different ways, but I like to do coordinate system. And then I click on that little dot, or sometimes I'll go into here, find the coordinate system, it's right there, click on that, and then it works. For this one, I'm going to do 2D adaptive clearing. So I would go right click, new operation, 2D adaptive clearing, and then I'll just edit the one that I have already. The tool I'm using is a 1/32 ball mill, my tool number 6, cutter 0.03125, length and stuff doesn't really matter. And then feeds and speeds, I use GWizard to calculate my feeds and speeds. These are wrong. 5100 RPM is my RPM. I want 2.5 for everything. So 2.5 inches per minute, which is crawling pretty slow, but it'll work perfectly. Select. Okay, so that's my tool and all my speeds and feeds. For the model, I just click on the face of the crown, because it's an extruded image, it works. And you want to machine cavities, because you can see here, it shows, I can't move my mouse, but it shows you want to machine the inside cavity and not the outside. And then for all your heights, you sort of just play with these until you learn them and figure out what they all mean. But this bottom one is how deep I'm engraving, so I'm going to go -3 thou from my origin, which is the origin, the fixture surface. I'm going to use a 3 thou step over, which is very, very, very tiny, but it's going to be awesome. And then lead in, lead out. This is a cool one, the rapid retract. So when it moves from one position to another within the cut, it'll just move it fast instead of air cutting really slowly. So that saves a lot of time right there. And that's about all there is to it, and now it's crunching, 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 and now it's done, but everything's in the way so we can't see it. There it is. So this is my tool path. It should look pretty cool, and it's such a tight step over, I don't know if you'll even actually see the spiral. But if you do, it'll look pretty cool anyway. Okay, so now I'm just going to post-process that. I'm using the generic Haas post-processor, tweaked a little bit for my Tormac application, and then I hit post, and then I click on this one, to the adaptive, my king. I think I want to replace it. And here's the code. It's a long code. How many lines? 5,500 lines. So then I drop that onto a USB stick. It's already there, and we're good to go. Alright, let's go to the garage. Alright, so I'm in the shop now. I've got the knife here. I'm going to take it apart so that I can get the clip off, because of course my screws are hidden from the back side. So unfortunately the knife has to come apart to get the clip off, but that's okay. Man, this looks so cool. Love this knife. Alright, here we go, disassembling. Alright, next up, moving over to the Tormac PCNC 1100. I love this machine. Alright, I was actually doing clips yesterday, doing more clips, because Eric comes to me and says, so, we have no more clips. So we fixed that. So on this fixture I can make 42 clips using only half the fixture. But this time I only made 35, left one row out, just because my material was that size. So yeah, what I'm going to do is get this guy's clip. I'm going to bolt it down to the fixture right about there. And I'll do that right now. So for those who are able to understand what I was talking about before, with the zero hole, the X0, Y0, Z0 hole being in a weird position, I can explain that real quick here. So to fixture the clips, I've got my Mighty Bite Back Magic palette here. So it's a palette changer with a sub palette and then a top palette. And this top palette lets me thread stuff in from the back side. So these parts are not being held down with vacuum, they're being held down with screws. And then this plate is screwed to this plate, and then this plate is vacuumed down to the thingy. Anyway, so because there were screw holes right here, I couldn't put a good probing zero hole right there. So it's in this subplate, as you can see. So that is my reference point. I take my digital touch probe and I go in there and I find the center of it. And then I put this on top and it works. So that's what that means. So anyway, I got the new clip mounted up. I just have to figure out how to manage this with one hand. The palette is aligned on these round and diamond pins. So that one's round, and you can see this one's a diamond shape. And then they go into liners there. So everything just goes together perfectly. Perfectly enough. And then screws, bolts. Okay. All these bolts, just, I didn't know how many to put on, so I just put them everywhere. So next up, what I have here is my Tormac digital touch probe, the passive probe. I use this tool pretty much every single day. So if you're going to get a Tormac, you need this tool. So it's basically a little digital sensor that anytime this tip goes off center or up and down, it sends a signal through these wires to the Tormac. So I'm going to use it to go down and touch the top surface of this clip so that I know exactly where the top surface is, and I can machine exactly 2 or 3 thou down from that surface, so my engraving is nice and perfect and consistent and not deeper than I intend it to be. Because a lot of times you'll buy material and it's called 1/8 inch material, but it's nowhere near 0.125. So you gotta measure. So yeah. And then with the vacuum palette system, like right now it's off, now it's on, I actually noticed a 3 thou suck down, even with all this weight and everything pushing down on it. So if I probe it now, it measures 0. If I turn this on, it measures -3 thou. So this has to be on when I measure it, when I probe it. And to do that, I just come over to the Tormac screen here, and then Z-probe, make sure that I'm in the correct work offset, which right now I am. G59P101 is the one that I'm using, and then I go set work offset, and you can hear it. And then it says Z offset updated. So I'm gonna hit this, and we can watch it. Perfect. Goes through the coolant and everything. Doesn't care. Look at all this rust! It's probably my fault. I don't think my coolant is rich enough, and I think I've always had it too lean. Hence all the rust. I get heck from it from a lot of guys, but whatever. I use my machine hard. Yeah, I think I just need to use a richer coolant. I need to buy more. I'm all out. Anyway, so the Z offset is now accurate, and now the code should just run perfectly. So sometimes when I run a new piece of code, I don't always trust it 100% perfect, and that's mostly me, making sure all my offsets are right and the tool is right and everything. There's a lot to think about. So oftentimes I'll just visually verify it, and I'll look through the code and make sure that all the numbers, the important numbers like the Z, work properly. So I've got tool 6 in the spindle right now, which is my 1/32 engraving end mill from Lakeshore Carbide, and then I'm going to get into the right fixture offset. I'm going to move the tool down to just like visually really close to the surface, and then check the numbers and make sure it's like close, so that I can go, yeah, that's probably going to work. It's not going to be like this far off and either not touch it or smash right into it, which happens a lot. So I'm in the right fixture offset. I've got my code open here, and I'm just going to move it down and take a look. Yeah, looks about right. Good. In my next video, which should be my next video because I'm going to film it after this, I'm fixing a tool crash that smashed a tool right into a part, and I have to do a really cool workaround to be able to make that part usable again. So the simulation told me it'll take about 10 minutes to do this, which is overkill, but it's going to be perfect. So while that's running, so like I said, I'm using a 1/32 ball from Lakeshore, and the interesting thing about that tool is that when you're cutting titanium, you want to use a sharp tool. When you're cutting steel or stainless, even a little bit hardened stainless, like the pivots that I'm doing, they're 42 Rockwell about. So I put my logo in there with the same tool. You can use a dull tool on those stainless ones, like for quite a long time, and it'll still cut and still make a pretty good looking engraving until all of a sudden the tool just breaks, and then it's gone. But with titanium, I use that same kind of worn out tool from cutting all those hard pivots into the titanium, and it smears and it gums and it just looks like crap, but it doesn't break, but it makes a horrible looking engraving. And then I put a fresh tool in and recut it, and it works perfect. So titanium likes, maybe keep all your fancy engraving end mills like that specific for titanium, or just always use fresh ones or something. But yeah, the steel, it seems to last for a long time in steel and a long time in titanium, but when I mix them back and forth, it just doesn't always work. So yeah, fun fact. Looking pretty good. Alright, we'll check back on that in a few minutes. Alright, moment of truth. It just finished. See how she looks. It looks a little burry around the edges. Getting closer. I don't know why it got so burry right there. That's weird. It's fine on this side, but it's not so fine on this side. That's weird. don't know, maybe the end mill wasn't as new and sharp as I thought it was. Because the last job I did with that end mill was fixing that of a dull end mill, so that might have dulled it a little bit. But I mean, it is a teeny tiny tiny little ball end mill. There's not much to it. Maybe I know this one. It's the exact same thing, but I know this one is super sharp because I've only done one other engraving with this end mill. So maybe I'll just run the coat again with this end mill, and that'll clean it up. Maybe. Yeah, we'll try it. Doesn't hurt to try it. I also wanted to say, because this clip has already been anodized and stonewashed and is perfect, I'd rather machine it perfectly so that there's no finishing work to do on it. Because otherwise, if this was an unfinished clip, I could almost just throw it in the tumbler right now, and the tumbler will scrub out all those burrs. But I don't want to do that. I want it to be perfect. So a sharp end mill should do that. So a lot of times when I want to look at an end mill really, really close and to see if it's chipped or dull or broken or whatever, I've shown this in previous videos. I can't remember which one, but I've got a little loop, a magnification lens. I stole this out of a scanner that was broken. And then recently I bought this one from Amazon for like $8 or something, and it comes with built-in LED, which is actually super duper handy. I think this was labeled as a 40x, 40 times magnification, and I love it. Super love it. I want to get some more, because Eric keeps stealing this one from me. And probably if I can find some more with even more magnification, that'd be good. But I love the LED, so yeah, I mean, you just get to look super duper duper close. And I can tell that my number 6 is, it maybe looks a little worn on the edges, but it's such a tiny tool that even with 40 times, I'm having a hard time really seeing it closely. That can't be 40 times. I don't know, maybe. Anyway, alright, so double the C, double the S, that's how you spell success. That fresh end mill made a big difference. Cleaned everything up. There was a tiny little burr, but my finger was able to just pop it right off. Alright, let's get this knife together. So I figured out why there were burrs just on this side. Because since this came off of a finished knife, Eric had already put a bend into it to give spring tension for your pocket. And I didn't think far enough ahead. Like, I wondered about it, but I didn't go ahead and unbend it so that it's flat. I should have. So the clip sat in the fixture a little bit up. So this corner got deeper than the left side corner. You can see it quite clearly. So the left side corner is not very deep at all, and the right side is quite deep. Hence the chatter and the, what are they called, the burrs. Whoa. But yeah, other than that, I mean, I'm quite happy with it. And it looks stellar. Just killer. Alright, she is all back together and absolutely gorgeous. That looks so cool. Super cool. So that is how I do a super custom engraving. Sometimes I will just do a simple outline. Like if I just outlined this crown instead of filled it in, it would have been a lot easier to figure out. And a lot faster to machine and blah blah blah, but why do it the easy way when you can do it the awesome way? But it proves to myself that I'm completely undercharging for my time. I mean, you've watched this video, I don't know how long it's going to end up being, if it's 20 minutes or 40 minutes or whatever, but that's how long it took to do the video to make this part, to make this engraving. The actual engraving, the whole process that I went through, took a lot longer than that. I'm talking probably hours that I put into it. A lot of it's figuring out the process and the details and the tool paths and all that stuff. But you know, even everything you saw in the video where everything went pretty much smoothly, I had to redo the engraving once. That's kind of common sometimes when you're looking for absolute perfection. You know, it just takes a long time. So yeah, just to give you a bit of a perspective on what really goes into something like that, at least the way that I'm doing it. I'm sure there's always faster and easier ways to do it. There's other software that probably do it way easier, but this is what I have available to me. This is how I know how to do it, and I am able to bust out a wicked product. Oh, I love this damn steel. I'm telling you, my next knife for myself is going to be Damasteel. I actually put aside number 200 and I made it Damasteel. So I have the blade now, and I'm going to make another knife for myself. Because I have number 1, I have number 100, and now I have number 200, and that'll be mine. So anyway, that wraps up this Knifemaking Tuesday. This turned out amazing, and first impression?
Love it. No, that's wicked.
That's awesome sauce, isn't it?
Yeah. This one's so nice too.
Yeah. I was just telling everyone.
Wonderful.
Yep. All right. Toodle-oodle.
Peace.